Good morning, students. Up to the last lecture, we are studied about the dew point and humidity. Okay, in that point, we are studied that water vapors are present in our surrounding environment. Okay, due to the evaporation, water vapors are always present. Okay, so due to that water vapors, air become moist. Okay, and that moisture present in surrounding air is simply called humidity. Okay, then one topic also we are seeing, that is the saturated air. Okay, so in that we are studied what we know, where air is saturated or not, it depends on the how much water vapors are present in that air. Okay, we know this humidity is also depend on the temperature. Okay, if temperature is very high, then we see that at 40 degrees Celsius, if we take 1 kilogram of air, then we need near about 49 gram of water vapor to saturate that air. Okay, and also we see at 14 degrees Celsius, at 20 degrees Celsius, okay, we need only 14 gram of water vapor to saturate that given air. Okay, so there are also we studied that temperature is one important factor that affects humidity. Okay, if a temperature is low, then we see that humidity of air is very high, and if temperature is very high, then we see that humidity is very low. Okay, so such a way that we are studied about the humidity. Okay, and in the dew point we have studied that what happen if you take unsaturated air. Okay, unsaturated air means what? That air in which we can see that air is not fulfill of water vapor. Okay, we studied that certain amount of water vapors can be added in a air at particular temperature. Okay, so further that or after that limit, if you try to add water vapors, then that water vapor does not add in that given volume of air in that particular temperature. Okay, so after that what happen, that vapor start to convert into droplets, and that we call dew. Okay, means at a temperature where air becomes saturated. Okay, and excess of what our water vapors get convert into the water, that temperature is called dew point. Okay, simply the temperature at which dew is formed, or at temperature where air becomes saturated and excess water vapor gets convert into the water droplets, that we call dew. Okay, so generally we see this case in winter season. Okay, where at early morning temperature is very low, and due to that what happen, we see lot of dew are present in our surrounding. Okay, so what happen, as the temperature decreases, we know at 20 degree we need less moisture to saturate air. Okay, and we know in winter season temperature is very low, up to the 10 degree, 8 degree, 7 degree, so saturate all the air, water vapor need is very less, so that is why air gets easily saturated, and the excess of water vapors that are present in air, that gets converted into the water droplet, and that we call dew. Okay, and that temperature where air becomes saturated, the temperature is called what? Dew point. Okay, now today we have to see that is the absolute humidity and percentage relative humidity. Okay, so now first we have to see what is absolute humidity. Okay, so if we see definition of absolute humidity, then the definition is given that the amount of vapors present in air is measured by using physical quantity called absolute humidity. Okay, so if you want to measure, okay, how much water vapors are present in a given certain fixed volume of air, okay, then to measure that amount of water vapor in given volume of air is measured by using this quantity is called absolute humidity. Okay, so now what is absolute humidity? Actually, the mass of vapors present in unit volume of air is called absolute humidity. Okay, so if we take unit volume of air and we measure the water vapors present in that unit volume of air. Okay, so whatever the mass of the water vapors that are present in a unit volume of air is called absolute humidity. Absolute humidity is simply what? The mass of water vapors which are present in the unit volume of air is simply called absolute humidity. What? Absolute humidity. So now next topic, that one formula is given there. Okay, percentage relative humidity. Okay, so this concept relative humidity generally we are used to say our surrounding environment. Okay, so generally sometimes we are say that air is very dry. Okay, means what? Dry means what? Okay, second is air is very humid, means what? On what basis generally we study the given air is dry or volume? In that case we have to use this concept, that is the percent relative humidity. Okay, so how that percent relative humidity is calculated, that we have to see. Okay, so the formula of percent relative humidity is given here. What? The actual mass of water vapor contained in the air in given volume. Okay, so to calculate percentage relative humidity, first we have to do what? We have to calculate, we have to first of all take certain volume of gas. Okay, fixed volume of gas we have to consider, and then we have to measure the actual mass of vapor contained in the air in a given volume. Okay, so simply we have to measure mass of a vapor present in a given volume of air, then divided by what? The amount of vapor needed to make air saturated in that volume. Okay, so whatever the air we consider which is not saturated. Okay, so we have to consider now saturated air. Okay, so we know in saturated air what happen? Air is become fulfilled with water vapor. Okay, no further water vapor get added into the air. Such air is simply called saturated air. So we have to add, we know this whatever the volume of air we are consider, that volume is unsaturated. Okay, means some water vapors may be added into this air. Okay, so now see, first we have, what we do, we have to take mass of vapors present in that volume divided by, okay, amount of vapor needed to make air saturate in that volume. We know to make saturate of that air we have to add some hot water vapors. So how much water vapors we have to add to make that air saturate, that volume we have to take at the denominator. Okay, so means we have to take a ratio of mass of the water vapor present in that volume divided by how much water vapor needed to make that volume saturate. Okay, that air saturate. Okay, so this ratio of mass of vapor divided by, we can see that amount of water vapor needed to saturate that vapor into 100 is called the percentage relative humidity. What? Percentage relative humidity. Okay, so it is the ratio of masses of vapor, but which vapors? In here in numerator we have to take mass of actual water vapors present in the given volume divided by what? How much water vapor we needed to saturate that given volume. Okay, so that ratio is we have to take here and multiply it by 100. Okay, then we get what? The percentage relative humidity. So you have to remember here this formula. Okay, percentage relative humidity is not simply the amount of water vapor present in a given volume of the air divided by amount of water vapor needed to make that air saturate. okay, into 100. Okay, first of all, for that we should know the meaning of saturate air. Saturate air means what? Saturate air means what? The air which is fulfilled with water vapor. Okay, further you try to add water vapor in such a air, such a saturate air, then you will find that that water vapor does not added in that volume of gas. Okay, so whatever the water vapor we add in the gas, that all again get converted into the water. Okay, so I told you the example of sugar and water solution. Okay, if you add sugar continuously, we adding sugar in that water, then one point will become where sugar does not dissolve in the water. Okay, so such solutions we are called saturated solution. Same way, saturated air means what? The air in which water vapor are fulfilled. Further that we can't add water vapor, and if you try to add water vapor, then that all water vapor again get converted into the water. Okay, so certain limit is there how much water vapor we can add in a given volume of air. Okay, that also depend on temperature. If a temperature is very low, then we need small amount of water vapor to saturate it. But if temperature is high, then we see large water vapors, we need large mass of water vapor we need to make that air saturate at higher temperature. Okay, so that humidity is a concept which depend on temperature. Okay, if temperature is very low, then we say air is very humid, and if temperature is high, generally we say dry air. Okay, which air? Dry air. So look at how this relative humidity concept is used to determine the our climate. Okay, so, but first of all we have to know this formula. Percent relative humidity is given by actual mass of vapor contained in a given volume of air divided by the amount of water vapor needed to saturate given air into 100. Okay, the amount of water vapor needed to saturate the air, and numerator the actual mass of vapor contained in the air. Okay, so into 100, this ratio is simply called the percent relative humidity. So this formula you have to remember. Okay, this is also one important formula. Okay, now we have to see how this concept percent relative humidity is used to determine the our climate. Okay, so we know percent relative humidity is a ratio of what? The amount of water vapor present in a given volume of air divided by what? The amount of water vapor needed to saturate that given air into 100. Okay, so now here, if percent relative humidity is 60%, okay, means that ratio, answer of this ratio is a 60%. Okay, that is the 60. Then if the relative humidity is greater than 60 degree, 60%, sorry, 60%. Look at relative humidity is greater than 60%, okay, is a 60%, then such a air is called humid air. Okay, such a air is called humid air. And if relative humidity is less than 60%, then such a air is called dry air. Okay, such a air is called dry air. Okay, so look at relative humidity is what? It is the ratio of actual mass of a water vapor present in a given volume of air, okay, divided by what the amount of water vapor needed to saturate that water vapor, okay, that air, okay, into the 100. Okay, so if that ratio, okay, is 60%, means what, 60, okay, simply not 60, if the relative humidity is a greater than 60, then that air is called humid air. Okay, and if the relative humidity is less than 60%, okay, then that air is called dry air. Okay, so simply our climate is depend on this concept of humidity, and we know humidity is also depend on temperature. Okay, so that is why in summer season temperature is very high, so what happen, air are not become easily saturated. We need large amount of water vapor. It contains large amount of water vapor, okay, because temperature is 50-55 degrees Celsius. Okay, so such air is called dry air. Which air? Dry air. Okay, where relative humidity is less than 60%. How much? Less than 60%. So such a case generally we are seeing in summer season. Okay, where relative humidity is less than 60%, and humid air where relative humidity is greater than 60%. Okay, so such a air is called humid air. We know at winter season where temperature is very low, so water vapor content, whatever the water present in air, that are sufficient to saturate it at that temperature. Okay, so such a air where the relative humidity is greater than 60% is called humid air, and such a case generally we are seeing in winter season. Okay, so that is about the relative humidity. Okay, so here you have to remember what is humidity. Humidity is not simply the amount or the moisture present in air, that simply called humidity. Okay, so then we see absolute humidity. Absolute humidity means what, simply the mass of water vapor present in a given volume of air is called absolute humidity. Then the concept of relativity we have studied, that important to tell our surrounding environment whether it is humid or dry. It depends on this relative humidity, and relative humidity is what? It is the ratio of mass of water vapor present in air at a given volume divided by the needed amount of water volume to make that given volume of air to saturate it into 100. Okay, so that formula is also given in our book. So this topic you have to remember. Okay, so the remaining topics we will see from tomorrow's lecture. Thank you.